So we're going to take a look at 1.4 pairs of angles today. Before we begin, math humor time. Teacher, today we are going to learn about complementary angles.
Student, does that mean that the angles are nice to each other?
But
You guys, these don't get any better, so take it as it is.
So, we're going to take a look at the warm-up. We have 5 warm-up problems that we're going to throw you through. Why don't you go ahead and take a look at them. Pause the video at this point in time, and when you're set and ready to go, start it up again. We'll have the answers written down for you. FYI, the other 2 are going to be on the other slide. So taking a look at the first one, hopefully you ended up naming the angle utilizing just the vertex, so you could say it angle M. You could also call it angle LMN. Remember what Ms. Flanagan said in the previous lesson about angle naming. You have to pick one from each side along with the vertex sitting in the middle. So it could be LMN, you could say KMN, or you could say NML. You could also say NMK. I don't ever want to see 4 points, though. It's always got to be 3. The middle one's the vertex. So, of course, that brings us to the next question. Name the vertex of the angle at the right. Well, the vertex of the angle is M, because that is the point that contains both sides of the angle. In 3, if we're talking about the measure of the angle OPR, we've labeled it as 4x. We've got angle RPQ was 3x plus 11, and the whole angle was 8x plus 2. Of course, this is our part plus part equals whole, so we wrote it out. Part plus part equals the whole, solved, and we ended up getting x is 13. And of course, that's all we had to do because all we had to do was find the x. All right, let's go ahead and take a look at the next 2. I'll give you a minute to pause the video, try these out on your own, and then come back and we'll have the answers written for you. So for number 4, it said use the angle addition postulate to complete the following. They told us that C was sitting inside the angle ZAB. Therefore, if we took a look at it, it was measure of angles ZAC plus the measure of angle CAB would give us the measure of angle ZAB. Very important that you remember with the angle addition postulate, please remember to put the M's in front of your angles. Number 5, if they told us that EG was bisecting our whole entire angle DEF, that meant that we had an angle bisector and our 2 angles were indeed congruent. So if we labeled the first angle as 3x plus 20 and the second one as 5x minus 8, we would set them equal to each other and solve, and we ended up getting x equals 14. And that's all we had to do because it only said find x. So let's go ahead and introduce you to perpendicular lines. Perpendicular lines are 2 lines that intersect to form right angles. So if I've got line A, we're going to do line A and line C. They intersect, and we know they intersect to form a right angle because we told you about the box symbol meaning a right angle. And when they intersect to form right angles, we call them perpendicular. Now you might be thinking, what is this thing, this upside down T? That really just means perpendicular. That is the symbol for perpendicular. So if you see an upside down T from now on, it is perpendicular. So another term we're going to take a look at today is adjacent angles. And when we talk about adjacent just means next to each other. So adjacent angles are 2 angles in the same plane that have a common vertex and a common side, but they don't share common interior points. So if we were labeling this or listing this, we would say that angle RTN and angle NTD are adjacent because they are next to each other and they share a common side, but they do not share common interior points. Another type of angles we're going to take a look at are vertical angles. Now, vertical angles are non-adjacent, meaning they're not next to each other. They don't share common sides, any of that good stuff. They are non-adjacent angles. They're formed by 2 intersecting lines. So in this case, I've got this line and this line. And when they intersect at this middle point. And if I take a look at the angles 1, 2, 3, and 4, I automatically know, well, 1 and 2 are next to each other, so they can't be vertical angles. But 1 and 3 are across from each other, and those are vertical angles. They are non-adjacent. They're not next to each other. And they are formed by 2 intersecting lines. So angles 1 and 3 are vertical. And if you can also pick out another pair, you should probably say that angles 2 and 4 are a pair of vertical angles. Now, if you've noticed, I did mark them with arcs, and I marked them with arcs because of this very, very, very important fact. Vertical angles are indeed congruent, and when we say they're congruent, that in this case means that if I was looking at angle 1, we would say angle 1 would be congruent to angle 3, or you would say that angle 2 is congruent to angle 4. And when angles are congruent, they do indeed have the same measurement. Remember that. The next new term we're going to talk about are linear pair. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. So if we take a look at this example, we are looking at angle 5 and angle 6 here. They are next to each other, so we consider them to be adjacent. And this is a ray FR, that's the common side. But if you notice, they're non-common sides, so in angle 6, ray FY, and in angle 5, ray FW, those are our non-common sides. And those non-common sides do indeed form opposite rays. So this would be considered a linear pair. So if I would say angle 5 and angle 6 form a linear pair. Now, very important in the bold, if you see this, it does say that the sum of the measures of the angles in a linear pair is 180 degrees. That would mean that the measure of angle 5 plus the measure of angle 6, in this case, would equal 180 degrees. Because it makes sense, they actually form somewhat of a straight angle, therefore it should be 180 degrees. Example. So we're going to take a look at this example. In this, you're going to tell whether the angles are only adjacent and form a linear pair, or not adjacent at all. So we're going to take a look at A together, and then you're going to do B and C. In A, it says angle AEB, so angle AEB is right here. And angle BED, so we're going to trace BED out with a different color, BED. Looking at these, would these be considered adjacent and form a linear pair, or not adjacent at all? Well, I do notice that they are next to each other, and when they're next to each other and they don't form any, they don't have any interior points in common, they are considered adjacent. But better yet, they do indeed form a linear pair because their non-common sides are opposite rays. So for A, you would say they are adjacent, I'm going to abbreviate, and form a linear pair. Go ahead, try out B and C on your own, and we'll figure out if we ended up getting the same answers. So for B, angle AEB and angle BEC, since they are right next to each other and they do not share any common interior points and their non-common sides are not forming opposite rays, we would consider them to be adjacent. In part C, angle DEC and angle AEB, notice they do share a common vertex, however they do not share a common side, therefore they are not adjacent.
All right, you guys, we're coming up to two terms that's going to be used for the rest of the year. You will hear these words up until the very last day of class. We've got something called supplementary angles and complementary angles. Supplementary angles are two angles whose measures have a sum of 180 degrees. So I could use the example of having an angle of 40 degrees and having an angle of 140 degrees. When you add these together, take their sum, they equal 180 degrees. One thing that you should remember is that a linear pair, will always be supplementary. And the reason why is because these two angles form to make a line to begin with. And a line is 180 degrees. Next one's going to be complementary angles. Complementary angles, very similar. It's just instead of having a sum of 180 degrees, we have a sum of 90 degrees. So this could be, for instance, a 30-degree angle. Oh my gosh, that was so bad. I'm sorry, you guys. Let me erase that for you. I'm sorry.
You're apologizing.
I am. It's bad. So let's say I've got an angle of 30 degrees and I have an angle of 60 degrees. When you add when you take their two numbers and add them together, they make a sum of 90 degrees. All right, on to the next example. You guys, these are my favorite. I love these. These are like little puzzles. My big key thing that I always tell all of my students is fill in your picture first. If you fill in the picture as best as you possibly can, getting to these answers is really, really simple. Okay, so we're going to use the information that's given to us. to fill in our picture first, then we're going to go ahead and answer 1 through 5. So first things first, they tell you that RC, right here, oops, and MY are perpendicular. We just learned perpendicular lines create right angles, correct? So this ends up being 90 degrees, along with this one, and this one. Okay, they also tell you that angle BTR is right here. This is 25 degrees. They want you to find all of the other angles. Well, using what you've just learned about the types of angles and their degree measures, you should know that if angle BTR is 25, across from it, CTF is its vertical angle. This should also be 25. Remember, vertical angles are congruent. Now we also have some more information. We know that these are 90-degree angles, and if this part's 25, using your angle addition postulate, you can figure out that if you were to take 90 degrees, subtract the 25, it would give you YTF as 65 degrees. Now again, if YTF is 65 degrees, the vertical angles make BTM also 65 degrees. So I filled in my picture. I would like for you to go ahead and fill in 1 through 5, please. Okay, you guys, let's take a look for BTM right here. We should have known that this is 65 degrees. We actually filled it in ourselves. RTY, you should know, is 90. That's our first thing that we figured out. BTY is actually a combination. If you take a look at BTY, we are going from here, oops, all the way to here. So you actually had to add part plus part equals whole, you guys. 90 plus 25, that gave you 115. CTF, we figured out with vertical angles, it's 25. And CTB was a combination of these two angles here. So you had to add 90 and 65 to give you 155. These can be a lot of fun, you guys, but remember, please fill in the picture first. Once you fill in the picture, then go ahead and answer the questions that they have. All right, next example, write an equation and solve to find the measure of each numbered angle. When you encounter something like this, the first thing that I want you to do is actually tell me what type of angles they are first. Then from there you'll know exactly what you should do to help you solve for your variable and find your angle measures. So the first thing I'm going to ask you is, angle 1 and angle 2 are what type of angles? Well, hopefully when you look at angle 1 and angle 2, you see that the type are a linear pair. Okay? From there, I want you to think, what do I know about a linear pair? Well, a linear pair, these should be supplementary. Meaning what? They should add to equal 180 degrees. So these should add to equal 180 degrees. Okay, once you get this part down, then I want you to worry about this part up here. It says angle 1 is 2x plus 2, and angle 2 is 6x plus 10. They want you to solve to find the measure of each angle. Well, I already just figured this out. I have to add them and set it equal to 180 degrees because they're supplementary. So we'll take 2x plus 2, add it to 6x plus 10, and set it equal to 180. Go ahead and pause me. I want to know what x is, please. All right, hopefully you found that x is 21. Once you know that x is 21, you can go ahead and plug that back in to find your angle measures. Well, the measure of angle 1 is 2x plus 2. So if I plug 21 in there, I get 2 times 21, which is 42, plus 2 gives me 44 degrees. Measure of angle 2 is 6x plus 10. So if I take 6 times 21 and add it to 10, we should get 136.
How do they match up? Yeah.
Yep, so you check to make sure, do they add to equal 180? Yes, they do. So we're good to go. Yeah. All right, you guys, I want you to try number 2. Remember, first things first, you tell me what type of angle it is, what you know about it, then you can go ahead and solve and find your angle measures. So I want you to try number 2, then we'll come back together and we'll see how you did. All right, you guys, the first thing you should have done is realize that these are vertical angles. Okay, they are across from each other. Second thing you should have realized is vertical angles are congruent. Okay, if they're congruent, that means that their measures are equal. So you should have set these equal to each other. Once you set them equal to each other, you should have noticed that x is 16. Then once you plugged it back in, you'll notice that both of them just so happen to equal 62 degrees. And it's good that they both equal 62 degrees because they're supposed to be congruent, remember? All right. Try number 3. Remember, I'm looking for the type of angles. I'm looking for what you know about them. Then I wanted you to find x and then tell me what they are. All right, you guys, you should notice that these actually come together to make a right angle. That makes these complementary angles, meaning they add to equal 90 degrees. So if I take x plus 10 and add it to 4x, it should give me 90 degrees. When you solved for x, you should have gotten 16. And when you plugged it back in, you should have gotten 26 and 64, which just so happened to add to equal 90 degrees. Okay? All right, so these next examples are a little bit different. The first one says if the measure of an angle is 47 degrees, then the measure of its complement is what? Big key word in there, complement. This should make you think of complementary, meaning that our two angles, something plus something else, should equal 90 degrees. Well, I know one of those angles is 47, and I want you to find the other one. Well, it's simple. All you have to do is take 90 degrees, subtract the 47 you already have, and you figure out that the complement of 47 is actually 43 degrees. Okay? I would like for you to try number 5, please. Pause me, and then we'll see what we get when we come back. All right, you guys, this one's no different. Do not let this x freak you out. Okay? Just like we did in the first one. We said that in order to get our extra value here, we would have to take 90 and subtract what we had to get what is left over. It's no different. To find the complement, you take 90, subtract the part that you have, 7x minus 12, and you come up with the complement, what's left over. Well, it's 102 minus 7x. Yes, you can have an x in your answer. So for number 6, very, very similar. If the measure of an angle is 34, find its supplement. The only difference here is the word. We don't have complement, we have supplement, meaning they should add to equal 180 degrees. I would like for you to please finish up 6 and 7. We'll come back together, see if we have the same answers. All right, so in this first one, if we take 180, subtract what we have, the 34, we get its supplement, which is 146. In the last one, if I take 180, subtract what we have, the 7x minus 10, I end up getting the 170 minus 7x. Remember, you guys, don't freak out about this x. It's okay to have that in your answer.
So in this example, we're going to take a look at complements again. It says that an angle is 10 degrees more than 3 times the measure of its complement. Find the measure of the complement. So when we see complement, like Ms. Felinek said, we are going to go ahead and talk about angles that add up to 90 degrees. Well, the easiest way for me to do this is probably just to draw two angles that add up to 90 degrees. Okay, so our two angles that we have here are going to be complementary because they add up to form that right angle. Now, I do not know what the complement is, so what we're going to do is we're going to label one of the angles as an x. So that's my complement. Then, going back to the first sentence, it says that the angle is 10 degrees more than 3 times the measure of the complement. So 3 times the measure of the complement with 10 degrees more is a 3x plus 10. Now that we have both of these angles labeled and they are complementary, that means if we add them, the sum of their measures is going to equal 90. So there we go. If we solve this out, we're going to get 4x equals 80. So then x is 20. So if x is 20, it said find the measure of the complement. That's what we had labeled first, was our complement. That means our complement is 20 degrees.
All right, a word problem. This time they have the picture labeled for you. It's beautiful. Let's just read through it, figure out what the heck we have to do. It says light passing through a fiber optic cable reflects off the walls of a cable in such way that 1 is congruent to 2, 1 and 3 are complementary, and 2 and 4 are complementary. They then tell you that angle 1 is 47 degrees. They want you to find the rest of them, 2, 3, and 4. Okay, first of all, complementary means that they add to equal 90 degrees, correct? Okay, so let's go back through. The first piece of information they give us is that angle 1 is congruent to angle 2. Well, if the measure of angle 1 is 47, and 1 and 2 are congruent makes their measures equal, so that makes the measure of angle 2 also 47 degrees. Now all we have to do is take care of this complementary business. They say that 2 and 4 are complementary. Oh, that was a bad color to pick. Sorry, you guys. We don't have anything better. 2 and 4 are complementary. That means that they add to equal 90 degrees. Well, if one of them is 47, how do I find its complement? Well, you would take 90, subtract the part that you know, and you would get the part that you want, which is 43 degrees. So that makes the measure of angle 4 43 degrees. Likewise, the other way, angle 1 and 3 are also complementary. Well, since this is 47 as well, that makes the angle 3 measure 43 degrees as well. All right, you guys. We'll talk about our whisk tomorrow.